हेलो एवरीवन एंड वेलकम टू फेस वाला गाइस। कैसे हैं आप लोग सब? होप कि आप okay. So hello everyone, welcome to face वाला guys. Hope you all are doing well and your preparation is going to up to the mark. So in the last class, I think hello Anurag. In the last class, I think very good evening first of all. Yes, in the last class, I think we have covered the power and energy signal basics, and in today's class, we are going to solve multiple problems. Okay, and the statistics, as far as your statistics is concerned, I think that I have covered many statistics in which I have covered the periodicity and I have covered, that is, energy and power. This is energy and power. After that, we will start a symmetry on signals. So before starting the class, if my voice is clear, please let me check from my end also. Hello. Yes, I think audio and video is clear. So let's start now. Yes. So what we covered in the last class? So we have covered first, that is a discrete time, ETS periodicity. And second, we have covered, that is the energy and power signal. So let's recap. Hello Pratiksha. Let's recap a bit. So what I said about energy and power of a function, I said that if signal is xt whose discrete version is xn, then in continuous time energy Ex is given by minus inverted to infinitive xt into x conjugate of t dt. Okay, xt into x conjugate of t dt. And if signal is completely real, then this can be also written as Ex equal to minus inverted to infinitive x square t dt. This can be also written as minus inverted to infinitive mod xt whole square dt. Mod xt whole square dt. This is what my energy is. So this is what my Ex is. Now in today's class, I will tell you that how will you recognize that whether the signal is energy or power. That we will see in today's class. But the point is that, see here, we define the power in this way. We define the power P equal to 1 over T with minus T by 2 to T by 2 x of t into x conjugate of t dt with the t tending towards infinitive. This is what my power of a function is. So I said that, example, I said that e to the power minus of alpha t ut was the energy signal, and e to the power minus j omega naught t was my power signal. In the last class itself I derived. Now the same thing I derived for discrete time. For discrete time, for DTS, I say that energy Ex is given by summation n is equal to minus infinity to infinity mod xn whole square, or this can be also written as summation n is equal to minus infinity to infinity xn into x conjugate of n. Exactly the same thing. Okay, exactly the same thing we have, xn into x conjugate of n. This is what my energy, and the power Px is given by 1 over 2n plus 1 summation n is equal to minus n 2n xn into x conjugate of n, with n tending towards infinity, with n tending towards infinity. So this is what my completely power signal, power of a function, and that's what a energy of a function in continuous time and in discrete time. So this I covered in the last class itself. Okay, now I have given you multiple problems like this one. See here. So today's topic is to first solve all homework problem, and second is to cover one of the very important function, that is bounded and unbounded function. So I have to cover this in today's class. Is it clear? Everyone, if this point is clear to you, then please let me know so that I can proceed further. Okay, now let's start. So I have given you a lot of problems like this one. See here. This is nothing but my homework I have given you in the last class, that find energy, and in the some slide I have given you to find out the power, and in some slides I give you that find both. So let's calculate all the energy and power, and let's draw some of the very important conclusion from these slides, from these energy and power. Let's do it. Let's take one by one. So the first was e to the power minus of 2t times of ut. Let's find out the energy of this function. Since it is a real function, so energy E is defined by minus infinity to infinity xt into x conjugate of a. One time I write, and now I know that, see here, now I know that it's a real function, so conjugate will be same. So it is minus infinity to infinity e to the power minus of 2t into ut into e to the power minus 2t into ut times dt. And when you solve this function, very good evening Vaishnavi, when you solve this function, this comes out to be 0 to infinity e to the power minus 4t dt, and when you solve, it comes out to be 1 by 4 joule, because this can be written as 1 by 4 e to the power 0 minus e to the power minus infinity, which is nothing but my 1 by 4. So it is a 1 by 4 joule. That's what my Ex is. Don't forget the unit of this function. So this is what my energy of this function is. Let's talk about the second one. Second one was e to the power 2t u minus t. So xt was e to the power 2t into u minus t. Let us find out the energy of this function. So how you will find? Same, directly I am writing minus inverted to infinitive e to the power 2t into u minus t and e to the power 2t into u minus t, and that's what my energy is. So u minus t exists. U minus t will exist for, that is 1 for t less than 0. That is from minus infinity to 0 and 0 else. So I can use this as limit minus infinity to 0 e to the power 2t into e to the power 2t dt, and when you solve, it is minus infinity to 0 e to the power 4t dt, which can be written as again 1 by 4 and e to the power 0 minus e to the power minus infinitive with 1 by 4 joule. Hello Amrita. So that's what my particular energy of this function is. So energy of this function is again 1 by 4 joule. 1 by 4 joule. Yes. So it is equal to 1 by 4 joule. Let's talk about this one. See, third. Third was a discrete function, 1 by 2 to the power n un. But before that, let's talk about this sixth one. Let's solve this sixth function. Then we will take discrete as a whole. So third, I am assuming third to be e to the power minus of 2 mod t. E to the power minus of 2 mod t, which can be written as e to the power minus of 2t into ut plus e to the power 2t into u minus t. I told you that in general, if I have e to the power minus alpha mod t, which can be written as e to the power minus of alpha t ut plus e to the power alpha t u minus t. Okay, so this means that e to the power minus of 2t ut plus e to the power 2t u minus t, it is, see, how will you find out the energy of this function? Simply we know the energy of this function and this function already know. See, we already know the energy of e to the power 2t u minus t, which is 1 by 4 joule, and we know the energy of e to the power minus 2t ut, which is again a 1 by 4 joule. So if xt is a combination of x1t plus x2t, xt is the combination of x1t plus x2t, then the whole combination energy will be added. Okay, so what I'm saying is that, see here, the energy of this function would be like energy ex is ex1 plus ex2, and this is 1 by 4 plus 1 by 4, and which gives me 1 by 2 joule. But let us summarize this. Let us generalize this. Actually, see here, if it was e to the power minus of alpha t ut, the energy comes out to be how much? Directly I will write, it is 1 by twice alpha. Find it. E to the power minus of alpha t ut will have energy in general, this is the case. In general, we have this energy. Similarly, if we have e to the power alpha t u minus t, then the energy is again 1 by 2 alpha joule. That's what my energy is. Again, box it. Okay, So this is again a energy that you have to take care of, and hence if I have, let's say, e to the power minus of alpha mod t, then the energy would be 1 by alpha. That's the reason why e to the power 1 by 2 joule will comes into the picture, and hence it's the energy Ex. This is the case. Okay, this is what my energy of this function is, and hence it is a 1 by alpha joule. And energy is always actually energy is always positive, so you may use a mod on this one. You may use 1 by mod alpha, or let's say 1 by 2 mod alpha, like this. Alpha would be, if it is alpha is negative, there is neither energy nor power though, but it's okay, fine, we will see. Let's remove this mod sign. I will cover what will happen when alpha is negative. One by alpha. We will see this. Let's take now a discrete function. What was the discrete example? Discrete was this one. See, 1 by 2 to the power n un. So fourth is 1 by 2 to the power n times un. Let's find out the energy of this function. And how will you find out the energy? Listen carefully. See here, the energy Ex would be summation n is equal to minus inverted to infinitive xn into x conjugate of n. Xn into x conjugate of n, and this can be written as summation n is equal to minus inverted to infinitive 1 by 2 to the power n into un into 1 by 2 to the power n into un, and this will give me summation n is equal to minus inverted to infinitive, summation n is equal to 0 to infinitive 1 by 4 to the power n, because it is 1 by 2 to the power 2n un. What's the un? Un is 1 for n greater than equal to 0. So 0 to infinitive, you have this one. Now you know that summation n is equal to 0 to, let's say, infinitive alpha to the power k is 1 upon 1 minus alpha if mod alpha is less than 1. Mind it. If mod alpha is less than 1, then it is 1 upon 1 minus of alpha. Easily you can find out, see here, easily you can find out that this is nothing but my infinite GP series formula. Is it clear? So this is the infinite GP series formula, and which is written as 1 upon 1 minus of alpha, and hence it is equal to 1 upon 1 minus of 1 by 4, which I will say that it is equal to 4 by 3 joule. So easily you can find out the energy to be 4 by 3 joule. I am giving you homework. If I will take that I have a beta n to the power un, okay, then prove that the energy comes out to be 1 upon 1 minus, let's say, beta, if beta is less than 1, then only. If alpha is greater than 1, then the infinite GP series will not converge. It is equal to infinity. You know that from your high school maths. Yes or no? This infinite GP series will not converge. The value of this infinite GP series becomes a infinity. So that only exists. That's only exists when, mind it, that this is only possible. Okay. This is only possible when the beta, whatever the value you are taking, is to be less than equal to 1. Is it clear? Okay, let's come to the another one. Fifth question was very interesting question. It was a very interesting problem actually. Fifth problem was this one. See, this one. I'm taking this to be fifth one. 1 by 2 to the power minus n, u minus n minus 1. Let's check that whether this series, if I add all the samples, then whether it will converge or not. Whether it will converge or not. Let's do it. See here. Suppose I have, let's take a fifth one. Xn is 1 by 2 to the power minus n, u minus n minus 1. Let's do it. U minus n minus 1. Now first of all, understand and let's plot this function. Let's plot this function. See, what is the limit of u, this one, the u minus n minus 1. See, this can be written as, let's do it. See, the limit is u minus n defined by this one, u minus n minus 1, u minus of n plus 1. Let's start now. Let's start. See here, un is this. You know that this is my un. It is 0, 1, 2, 3, 4, 1, 1, 1, 1, 1. What we have to do? We have to first reverse it and then shift it by left by minus 1. When you reverse it, don't you think that I will get this one? That is 0, minus 1, minus 2, minus 3, minus 4, 1, 1, 1, 1, 1. This is what my u minus n is. And when you shift it, when you shift the limit towards 1, then the limit will comes out to be minus invertive to minus 1 because we are left shifting it. So what I am saying is that, listen carefully, let's plot this function. The limit for this one is minus invertive to minus 1. First let's check that whether this series will converge or not. Converge means whether the value is not going towards infinitive, that is, it will give you finite value or it will give you infinite value somewhere. Let's do it. See, when you put n is equal to minus infinitive, this becomes 1 by 2 to the power minus of minus infinitive, which is 1 by 2 to the power infinitive, which is equal to 0. Of course 0. But when you put 1 by 2 to the power, let's say 1 by 2 to the power what? A minus of minus 1, so this will gives you 1 by 2. So what I am saying is that, so this is a finite limit, means the values exist between 0 to 1 by 2 only. And what kind of plot I will get? See here, what kind of plot I will get, see here, between see, I will get a plot of, see, this kind of function. And so on. Like this. I will get a plot of this one. See, this is at let's say, remove this one. Say, this is at n is equal to minus 1. At 0, the sample value is 0. At 1 also, the sample value is 1. 0. This is 1 by 2. This should be 1 by 4. This should be, that's a 1 by 8, and so on. And at this will converge to 0. So at n is equal to minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So this is the exponential kind of function, a discrete exponential in which the exponential factor will decay like this, okay? And hence it has a finite energy. Since the value is not going towards the infinitive, after a few moments I will tell you that how by looking the function itself I will comment on the fact that whether the function is let's say it is an energy signal or power signal. But one thing is very clear, that this function is not going towards the infinitive. Okay, this function is having a finite value, and since it is a finite value, so purposefully we will solve that summation limit. Okay, let's do it. So let me check here. So let's take xn again. Xn is 1 by 2 to the power minus n u of minus n minus 1. Let's find out the energy first. And hence it is equal to summation n is equal to energy formula minus infinity to infinitive. Let's make a boundary here. Okay, so energy formula is summation n is equal to xn into x conjugate n. Yes or no? So the energy will be equal to summation n is equal to minus infinity to infinitive 1 by 2 to the power minus n u minus n minus 1 1 by 2 to the power minus n u minus n minus 1. Why? Because the function is purely real, and hence there is no such complex conjugate we have. Just now I told you that this limit exists from minus infinity to minus 1. So this is n is equal to minus infinity to minus 1, and hence 1 by 2 to the power, let's say minus of 2n we have. Is it clear? 1 by 2 to the power minus n, or you will say that this is n is equal to what? Minus 1 to minus infinitive 1 by 4 to the power minus n. Hello. See, in the summation limit, in integration, listen carefully, in integration, let me write here. In integration, if I put a to b, and suppose if I change the limit from b to a, then I have to put a minus sign. No problem. But in summation, if summation is n is equal to a to b, then it is same as summation n is equal to b to a. Exactly same. No minus sign. See, if you count 1 plus 2 plus 3 plus 4, whatever the result will gives you 4 plus 3 plus 2 plus 1. Exactly the same result you will get, because summation is always commutative in nature, but this is not commutative. This is a vector. Okay, it depends on direction also. Integration depends on direction also. That's why minus sign will come. So if I change the limit here from minus infinity to minus 1, I will change it to minus 1 to minus infinity here. Okay. Now how will you handle this limit? That's what the point is. See here. First of all, since it is a minus 1 minus everywhere, so what I'm doing is that I am straight away denoting n is equal to, let's say I'm denoting n is equal to minus n. Let's do it. N is equal to minus n, I'm straight away replacing. So this becomes a 1, this becomes infinite, this becomes plus n. This means that this is n is equal to 1 to infinitive 1 by 4 to the power n. I can write this in this way. Okay. Now what you will do? You will do n minus 1 to be equal to p, so that I know the GP series which exists for 0 to infinitive. Yes or no? So what I'm doing is that it is plus 1, so n minus 1 becomes a p, let's say. So if when n is equal to 1, p is equal to 0, and when n is equal to infinity, p is also equal to infinitive, because infinitive minus 1 is infinitive. But what is n? N is equal to p plus 1. N is equal to p plus 1. Very in the layman form I am solving this one. Though those who have a strong background of math, they will solve in just within a fraction of a second. But I have to take care of each and every student which have a label. I don't care about the label. Is it clear? So just do it. Here n is equal to, let's say, limit will be 0 to infinity, p is equal to, and hence 1 by 4 to the power n is equal to p plus 1. P plus 1. I can write this one. How will you write? I can write it as p is equal to 0 to infinity 1 by 4 to the power p into 1 by 4. Okay. And hence, this is the infinite GP series formula. 1 upon 1 minus 4 is the answer, multiplied by 1 by 4. And when you solve this one, this is 4 by 3 multiplied by 1 by 4 and gives me 1 by 3 as a 1 by 3 joule is a energy for this one. 1 by 3 joule is the energy for this function. Okay. If there is any mathematical error, please solve it. It will solve in this way only. Yes, so it is, the energy is 1 by 3 joule. Okay. So 1 by 2n un has an energy of 4 by 3 joule, and this have energy of 1 by 3 joule. Let's talk about a very interesting function. Let's talk about a very interesting function, okay? Last function, which is this one, 1 by 2 mod n. How will you write 1 by 2 mod n? Yes. Next is, which function? Come on. Fifth one, na? So let's talk about sixth one. Sixth. How will you write 1 by 2 to the power mod n? Now here the definition of mod n itself has a unique meaning behind it. See, when I talk about a mod t, then mod t is t for t greater than 0. It is minus t for t less than 0, and it is 0 at 0. This is this kind of function. See here. But if you straight away use this definition 1 by 2 to the power n for n greater than 0 and 1 by 2 to the power minus n for n less than 0. Hello? Then there is a one catch. See here, what will happen at 0? See, n less than 0, mind it that n belongs to integer. This means that what kind of limit I have here? The limit is from minus infinitive to minus 1. And n greater than equal to 0, this means that n greater than equal to 0, this means that, see here, this is equal to how much? This is, limit is 1 by 2 for 0 to infinitive. The limit is this one. Okay, 0 to infinitive. So what I'm saying is that when I say 1 by 2n, I'm using the limit 0 to infinitive. I am not using the 0 in this way, in second one. You understand my point or not? I'm not using this 0 sample in second one. So if this is the case, then this should be written as what? U minus n minus 1. If suppose someone asks you to write in terms of a step function, then I told you in the very first class that the limit can be written in terms of step. So this means that this can be written as u minus n minus 1. And how will you write this limit? This can be written as un. So what I want to say is that, see here, if you want to write 1 by 2 mod n, 1 by 2 mod n, then this is equal to 1 by 2 to the power n into un plus 1 by 2 to the power minus n into u minus n minus 1. This has the limits from 0 to infinitive. This has a limit from minus infinitive to minus 1. What is the plot of both these functions? See here, the plot of this function plot, when you put n is equal to 0, listen carefully, 0 to infinity. When you put 0 here, it will gives you 1. This means that you will get 1. And when you put infinitive here, it will becomes a 0. Don't you think that this will have, at n is equal to 0, this is 1, this is 2, this is 3, this is 4, this is 5. And hence, you will get this kind of function. like this. Here also. And this plot I already know. See, I have made this plot just in front of you. See, this plot I already know. So this means that this plot is what? What is the plot of this one? See, this plot I already know. It is start from -1, -2, at 0 it is 0. This is -3, this is -4, this is -5, this is -6. And this kind of plot I will get. And so on. So basically, look at the limit, please. The limit is from minus infinitive to -1. What is the limit here? 0 to infinitive. So there should be no overlapping. And when you add both this function, then what you will get? You will get, see here, what you will get? You will get 1/2 mod n, which is 1/2 to the power n un plus 1/2 to the power minus n u minus n minus 1. Okay, then don't you think that I will get this function? And so on, like this. So this is at n is equal to 0, this is at n is equal to 1, this is at n is equal to 2, this is at n is equal to 3, 4, this is at n is equal to -1, -2, -3, -4, like this. So this part, okay, this part, up to this part, this is the part which I will say that this is 1/2 to the power n into un, and this part I will say it is 1/2 to the power minus n u of minus n minus 1. Okay. What is the value? The value here is 1. This is 1/2. This is 1/4. This is 1/8. And so on. Same here. 1/2, 1/4, 1/8, 1/16, so on. Exactly the same. It is same as e to the power minus of alpha mod t. You remember the umbrella function in continuous time? It is same as the umbrella function that we have covered in the last class. See, we have covered the umbrella function, which is this, so that this value should be 1. E to the power minus of alpha mod t is e to the power minus of alpha t ut plus e to the power alpha t u minus t. You remember or not? So it is exactly the discrete part of this is this. The continuous part of this is this. Same umbrella function. But umbrella function in terms of nothing but my 1 by 2 modern. In general, any umbrella function, can be written as alpha mod n, where alpha mod n, where mod alpha is less than 1, then we have this kind of converge. See, this kind of converge. If on the other hand alpha is greater than 1, then it will go beyond like this. If instead of, let's say here it is a plus alpha t, then it will go in some, let's say, towards the infinitive, not towards minus infinitive. You understand my point or not? If I do not put here minus sign, if it is alpha mod t, then this should be going towards the infinitive. Why it is converging? Why it is going towards 0? You know, because the minus sign comes. Similarly, what I want to say is that if mod alpha is less than 1, then only you have a plot this one. If mod alpha is greater than 1, I am giving you the homework. Let's take alpha to be 2. Then in that case, mind it, this plot is going towards infinitive. This plot will go towards infinitive. You understand my point or not? So this can be written as alpha n un plus alpha minus n u minus n minus 1, and it will have a this kind of representation. That's the thing that you must know before handling these kind of problems. Is it clear? So now we are asked to find out the energy. So 1 by 2 mod n. The energy is nothing but my 1 by 2. This can be written as 1 by 2 n into un plus 1 by 2 to the power minus n u minus n minus 1. And the energy we already find out to be 4 by 3 joules. Just check it. See here 4 by 3 joules. And another one is energy is 1 by 3 joule. You remember? See here 1 by 3 joule. This is okay. So total energy would be, E is E1 plus E2 and 4 by 3 plus 1 by 3 will gives me 5 by 3 joule. So total energy is 5 by 3 joule. Total energy is 5 by 3 joule. That's what one of the most important points we have to take care of. Okay. I'm giving you the homework. Find energy of alpha mod n for mod alpha less than 1. A general expression I want. I want a general expression for alpha mod n. That's in the same fashion you have to derive this one. Okay. So that is all about energy. Let's talk about the power now. The power, we have to find out the power of these functions. A in CTS, 5 in DTS, un a cos omega ct plus theta, and this function e to the power minus t ut plus 5. Thank you, 𝐂𝐚𝐿. Very good evening. Let's do it. Okay. You know that power can be represented by x, can be represented by 1 over t tends to infinitive and minus t by 2 to t by 2. Xt into x a conjugate of t dt. This is what the power is. So let's talk about A. A in CDS, how you will write A? A is this one. See? A is this one. Okay? So let's find out here 1 by t minus t by 2 t by 2 xt is a into a dt with t tending towards infinitive. It is a square by t minus t by 2 to t by 2 1 dt and with t tending towards infinitive. That's what my power is. And this gives me power px is a square by t into t with t tending towards infinitive is simply a. Okay, easily you can handle this integration and get the answer. This is nothing but my a square. Let's talk about this one, 5 in DDS. Second one is 5 in DDS, mind. How will you write a constant in DDS? See, it is same. It is this one, constant everywhere. This is 0, this is 1, this is 2, 3, this is 4, this is minus 1, minus 2, minus 5 and so on. So what I want to say is that, see here, up to this part you will write it as un, and if it is 5, everywhere it is 5, then what you will write? So on, this is 5 un. But up to this part, this one, you will write this as, okay, let's go on, you will write it as, if this is 5 into u of minus n minus 1 with the fact that limit is from minus n to minus 1. Just now I have told you. So 5 u minus n minus 1 is the factor. So it is not required in this problem. So you know that power in DTS can be written as, power in DTS can be written as 1 upon 2n plus 1. Summation n tending towards f and summation n is equal to minus n to n, that is xn into xn. Yes or no? It is real. Okay, and this can be done as 1 over 2n plus 1 summation n is equal to minus n to n 25, 5 square, 5 into 5 with n tending towards infinite. Now you know that it's a finite GP series formula again. Finite GP 0 to n, finite GP series formula, which can be written as this 2n plus 1, check it please, upon 2n plus 1 with n tending towards infinite into 5 square. Answer is 25 watt. This is a finite GP series formula. If you add 1 from, let's prove it. If you add, let's say it is minus 2, minus 1, 0, 1, 2. Let's say add 2, 2, 2, 2, 2. Only 2, 2. Let's say 1, 1, 1, 1, 1, because 2 will come out. This 1, 1, 1, 1, 1 Then what's the answer? It is 1 plus 1 plus 1 plus 1 plus 1 gives me 5. Which is how much? N value is how much? It is from minus n to plus n. N value is how much? 2. 2 into 2 plus 1, 5. You understand my point or not? And whatever be the value. So for example, it is 4. Then 4 will come out. See, 25 was there. No? 25 will come out. You left with 1. So if you add 1 from minus n to n, then it will give you 2n plus 1. Very simple. And hence it is 25 volt. Very simple. But yes, let's talk about the third one. Third one was this one. See, third is un. Third is un. Easily you can find out third. Third is un. Exactly same. Power will be 1 upon 2n plus 1 summation n is equal to minus n to n. un into un. With n tending towards infinitive. With n tending towards infinitive. What you will get? You will get 1 upon 2n plus 1 summation n is equal to 0 to n. Why? Because step function starts from 0. Just now we have covered. This is n tending towards infinitive. And suppose if you add, let's say I am adding 0 to 1 to 2. 1, 1, 1, 1, 1. What you will get? N value is 2. What you will get? 3. I will get 3. So it is what? N plus 1. 2 plus 1 is, this is equal to n plus 1 upon 2n plus 1. N plus 1 upon 2n plus 1. Listen carefully. And with n tending towards infinitive, so to solve this limit, let's take n as a common. So 1 plus 1 by n upon 2 plus 1 by n with n tending towards infinitive, which gives me 1 by 2 volt. Easily you can handle this kind of problem. Easily you can handle this kind of problem. Yes. Next was this A cos omega ct plus theta. How will you handle this? A cos omega ct plus theta. Simply go by formula. P x is 1 over t minus t by 2 A square cos square omega ct plus theta dt. What is cos square theta? 1 plus cos 2 theta by 2, I think so. Check it please. 1 plus cos 2 theta by 2 is what my cos square theta. Check it. I can use this. If I am wrong, please correct me. Maybe, I think so that this is the formula. Because I never remember the formula, guys, please. That's a humble request from my side that if I, let's say, write the formula wrong, please correct me. Please don't judge me by this, because this kind of formula you mug in your, let's say, 11th and 12th examination. Please do not test the knowledge based on this, okay? Formula, I never remember. I always try to nothing but my derive. And that's the reason I lag behind many of the students, many of the aspirants and so on. But pretty sure that this is the formula. Here with t tending towards infinitive. 1 by t with t tending towards infinitive is minus t by 2 t by 2 is a square by 2 dt plus 1 by 2 minus t by 2 t by 2 1 by 2 t by 2 t by 2, it is cos of 2 omega ct plus 2 ct. I think so that this is correct. Now what is cos? See here, look at the cos. Cos function is this function. If you consider this to be minus t by 2 and this to be t by 2, what I am doing is that, don't you think that I am adding the signal over one period? No matter what is the frequency, but I am adding the signal over one period. And the total positive is cancelled by total negative, then don't you think that this one will gives me big 0. So see here, look at that, the total negative is cancelled by total positive. Area under the curve of sine function or cosine function is equal to 0, because whatever is the positive curve you will take, it will cancel by the negative curve. You left with this one, this will be a square by 2 into 1 by t into t, with the t tending towards the infinitive, and hence it is a square by. What is the most important point is that a cos of omega ct plus theta has a power of a square by 2. That means that does not depends on what? Frequency and a phase of a function. So power is not a function of omega c and theta. Case of sinusoids, this is one of the most important thing that you have to take care of. The power is not the function of omega c and theta. Easily you can handle this. Simply a square by 2 is the power of them. And the last question was this one. See here, last question was this one. And this is the function, this is a, and that was the power minus of t times ut. Suppose someone asks you to find out the power. What I am doing in these kind of problems, I will go by the general method. What is the power formula? Power is 1 by x, 1 by t over the limit minus t by 2 to t by 2, xt into xt if it is real, dt with t tending towards infinitive. This is what my power formula is. Simple. So what I am doing is that I am first, let's say, restricting over, let's say, from minus t by 2 to t by 2. Minus t by 2 to t by 2. So the expression can be written as, listen carefully, power p would be, see, between minus t by 2 to t by 2, between minus t by 2 to 0, between this, what I have is 1 by t minus t by 2 to 0 a square dt. Plus between this it is 1 by t 0 to t by 2 and e to the power minus t into e to the power minus t dt. Why I am not writing ut? See, ut will make the limit to be 0. Already the limit is 0. Already the limit is 0. Let's solve this with the t tending towards infinity both. Now what you will get, see here, what you will get is first of all a square outside, and hence a square is outside, power px is a square is outside into 1 by t, and it is a minus t by 2 to 0 dt with the t tending towards infinity, and it is plus 1 by t minus t by 2 to 0 0 to t by 2 is what? E to the power minus of 2t dt. Let's handle this. This is straight away a square, because it is 1 by t into t with the t tending towards it. Let's solve this one. T tending towards infinity here also. Okay? Plus 1 by t with the t tending towards infinity is 1 by 2 e to the power 0 minus e to the power t by 2. So it is and when you put the limit t tending towards infinity, here minus t. When you put t tending towards infinity, this becomes 0. This is 1. 1 minus 0 becomes 1. This is the whole thing becomes a 1 by 2. But when you put t tending towards infinity, the whole thing will becomes 0. See, this is 0. When you put t tending towards infinity, it is 0. So this is 1. 1 minus 0 becomes 1. 1 into 1 by 2 is 1 by 2. So this is the whole thing is 1 by 2. But when you put t tending towards infinity here, it becomes a 0. So answer is what? X. Px is a square. Very simple. Okay. So that's what a power of a function is, and I think I have read each power. Let's do it both. E to the power 2t ut. Instead of e to the power 2t ut, let's cover t ut first. Find both. First find out the energy. Energy is minus infinity to infinity. Minus energy infinity to infinity. Let's do it. Next class. Next page. T ut I am taking. Yes, T ut if I take, then let's talk about the energy. Energy is minus infinity to infinity T ut times T ut T ut. This will give me 0 to infinity T square times dt. When you solve, it comes out to be energy is infinity. Maybe it is a power signal. Let's check power. Power P is 1 by t, t tending towards infinity, minus infinity to infinity, sorry, minus t by 2, t ut times t ut is 1 by t, 0 to t by 2, t square dt, with the t tending towards infinity. When you solve, then you will get 1 by 3 t cube by 3, 1 by t into t cube by 8 with the t tending towards infinity. 1 t, this t will cancel out, but t square is there. When you put, then it comes out to be, what is going on? Energy comes out to be infinitive, power also comes out to be, is it possible? No, it's not possible, minded. No, it's not possible. Energy and power simultaneously never be infinitive. Either energy is infinitive or power comes out to be 0. Okay? But simultaneously it is awake. This means that this TUT is neither energy nor power. Neither energy nor power. Okay, let's have some conclusion. I solved nearly about 10 to 12 problems, and based on that, can I draw some conclusion in front of you? Yes, surely we can. See here, let us consider this one. Start with the energy. Let's take here a one page, and what I'm doing is that I'm writing a signal and a rough diagram I will make, and I will write the energy. So I have a signal, I have a plot in time domain, and I have a energy. Let's do it. Listen. See here, I have e to the power minus of 2 ut. First, right? E to the power minus of 2 ut. Then I have e to the power 2t minus t. Then I have e to the power minus of 2 mod t. Then I have 1 by 2 to the power n(un). And let's take 1 by 2 mod n. Then you will draw some conclusion. Let's make a quick diagram here. E to the power minus 2t ut, you know that it is a curve. Looks like this. E to the power 2t u minus t, the curve. E to the power minus of 2t mod t is a curve which looks like this. 1 by 2 to the power n(un) is a curve which looks like this. And 1 by 2 mod n is a curve which looks like this. And let's quickly write the energy here. Energy here was, it is a 1 by 4 joule. Again, it is a 1 by 4 joule. 1 by 2 joule. It was 4 by 3, I think so. And it is 5 by 3. Listen carefully. Let's talk about this one. Let's talk about the power. Let's do it. So let's make a signal, power, plot, and power. So first was, that is A in CDS, that was a 5 in DTS, then UN, then A cos of omega CT plus theta. Another one was a signal. A signal. Signal given by this. A cos omega CT, quickly we can make. UN plot is this. We already know the plot of UN. 0, 1, 2, 1. 5 DTS is this. Everywhere it is a 5. 0, 1, 2, 3, 4. -1, -2, -3. 5 everywhere. Okay. Forgive my drawing, please. 1, 1, 1, 1 everywhere. A is this one. And what about A cos omega CT? Let me change the color. A cos omega CT is this one. A cos omega CT is this one. A cos omega CT plus theta is this one. What is the power here? Power we calculated A square. It is 25. It is 1 by 2. It is A square by 2. And that was A square. That comes out to be another one. Yeah, this one. Here, in signal, energy or power. Sorry, plot first. Energy or power. Here, it is first I am taking TUT. You know that TUT plot is this one. Then second one was e to power 2 TUT. Now look, see, when you put 0, it comes out to be 1. But when you put infinity, what is the limit? 0 to infinity, no? When you put infinity, this comes out to be infinity. Don't you think that this is the plot which comes like this one? Okay. This is e to power 2 TUT. And another one was NUN. NUN is just a sampled version of this function. Means that I will have this kind of function. See, and so on. This kind of. Yeah. So this is the straightforward function which is going towards the input. This is at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. NUN. 0 gives me 0, 1 gives me 1, 2 gives me 2, 3 gives me 3, 4 gives me 4, 5 gives me 5, 6, 7, 8. Tell me, what is common in all these? What is common in all these three? Don't you think that they all are going to there? They all are going towards the infinite. If any function is, carefully, at any instant of a time, if the value is going towards infinite, then the function is said to be an unbounded function. This is a purely unbounded function. This is also unbounded function. Also a unbounded function. Unbounded function. Unbounded function. That is also unbounded function. Because definitely a value will go towards infinite. Also, don't you think that they are, if you take the energy, area in the curve of this function, then the area in the curve of this function comes out to be infinite. The area in the curve of this function comes out to be infinite. So let me say this conclusion, that all the unbounded infinite area functions, all the unbounded infinite area function is neither energy nor power. It is what? It is neither energy nor power. Neither energy nor power. Neither energy nor power. But let's take it energy one. Energy function. Let's talk about the energy function. See here. Yeah. Energy function. So don't you think that their value will definitely a finite one? Their area under the curve is also finite. They all are bounded plus finite area. Finite, bounded plus finite area. Bounded plus finite area. Area. Also bounded plus finite sum. Straight, na? So bounded plus finite sum. Oh, this is also bounded plus finite sum. What I am saying is that all the bounded finite area finite sum signals are always energy signals. See, look at this, they are having a finite energy. All the bounded finite area finite sum signals are always energy signals. Mind it, that's one of the beautiful conclusions. Similarly, if you talk about the power one, let's talk about the power. Here, yes, see, don't you think they are infinite duration bounded signals? I'm not talking about area. Infinite duration bounded signals. One thing is common, that they all are infinite duration, going towards infinite, going towards infinite, going towards infinite, going towards infinite. All the infinite duration bounded signals are, all 5 are power signals. Number 1, all the infinite duration bounded signals are power 1. All the infinite duration bounded signals are power 1. And periodic signals are power 1. Periodic signals are power 1. So, what I am writing conclusion, that infinite duration plus bounded, not talking about area, minded, that's the point, make it in a capital letter, that please, I'm not talking about area here, I'm just talking about that bounded. This means that the value is not going towards infinite. Infinite duration, that means that the duration is infinity, means minus infinity plus infinity. Okay, so what I'm saying is very simply that all the infinite duration bounded one are always a power signal. Always power. Okay. Energy signals, finite area bounded one. Finite area bounded one. Unbounded signals are neither energy nor power. Unbounded signals are neither energy nor power. Delta T is neither energy nor power, but delta N is definitely a. So hope that these things I have covered, whatever I have covered for, let's say, energy. This energy means bounded plus finite area. Energy. And we talk about power. This power, infinite duration, bounded signals. And we talk about neither energy nor power, that is unbounded, infinite area, unbounded signals. Simply write it, unbounded signals, neither energy nor power. These are the conclusions. Periodic signals. Periodic signals. We have drawn that periodic signals is the power signals. But mind it, vice versa is not true. Periodic is power. Periodic is power. But vice versa means opposite is not true. That is, see, this is power. This is power. But it is not periodic. It's not repeating. For periodic, it should be everlasting in nature, from minus infinity to plus infinity. Hope that these all conclusions, whatever I draw in today's class, is very, very important minded as far as the power and energy is concerned, and hope that these all things will clear your doubts, will nothing but my no doubts exist after that much of elaborated class. Is it clear? So what we have covered is we have covered problems, and we have covered bounded signals, and energy power conclusion. Energy power, hope that this thing is clear to you, and hence thank you very much guys. Thank you. If you have a doubt, then do ask the doubt. I am here for another 10-15 seconds. If you have doubt, do ask the doubt. The next class will be on the symmetry of a signal. Okay, we will talk about, the next class will be symmetry on signals, and I think with this the basics of signals, the very first chapter, covered. After this one, the basics of signal is covered. Okay, thank you very much guys. Thank you.